In today's walkthrough, we'll be looking at question 2 on the week 6 worksheet. So we're given the following sequence of letters, we were Hall. Part A asks us how many arrangements or how many ways are there to rearrange the letters in a we were Hall. So let's first count the number of letters of we were Hall. There's 11 letters, which means there's 11 factorial permutations. But we need to be careful because some letters repeat, so we end up overcounting. For example, the letter E repeats 3 times. The letter H repeats twice. And the letter L repeats 3 times. So we need to divide 11 factorial by 3 factorial times 2 factorial times 3 factorial, which is our answer. So the general idea behind this problem is that if we have a word with repeated characters, to get the number of ways to rearrange the letters of that word, we have to find the number of permutations and then divide by we have to divide by the repetitions, essentially. Okay, let's look at part B. Part B asks us how many ways are there to rearrange the letters of we were Hall such that W is before R and R is before A. So the first thing to notice is that in any arrangement of we were Hall, there is an ordering of the letters W, R, and A. For example, this is one ordering of those letters. We could have W come before R and R come before A. And this is the ordering that we want. However, there are 3 factorial orderings or permutations of W, R, and A. And only one of these satisfies the condition we want, which means we have to take our answer in part A, which is the number of ways to rearrange the letters of we were Hall, and we have to divide this by 3 factorial. Which is our answer. Okay, let's look at part C, which is pretty similar to part B. So we're asked, how many orderings of the letters are there in we were Hall such that all 3 E's are before A? So notice how similar this is to part B, except now we have repeated letters. So let's look at the string E, 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 A, which is what we want. Notice how in every rearrangement of the letters in we were Hall, there's some ordering of the letters E, 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 and A. And this is one of them. So how many orderings of this string are there? Well, there's 4 factorial permutations. But the letter E, or the letter E repeats 3 times, right? So we have to take that 4 factorial and divide by 3 factorial. And this gets us to 4. So there's 4 unique ways to rearrange the letters E, A. And remember, only one of these ways satisfies our condition. So we have to take our result from part A and divide by 4. So the general idea behind this problem is that if we want to find the number of arrangements of a word, we have to find the number of permutations and then divide by repetitions to avoid overcounting